So when we're determining conic sections, we want to look at the equation. We can tell by the equation whether or not the shape will be a circle, an ellipse, a hyperbola, or a parabola. For the case of circles, they'll always have the same amount of x squared and y squared, meaning the numbers in front of x squared and the number in front of y squared will be the same. Even if I change these to 2, I still have a shape of a circle. And changing them to 5, I still have a perfect circle. So let's go back to a perfect circle that has a radius of 10 units. We can change this equation to become an ellipse. All we need to do is make the coefficients of x squared and y squared different. For example, if I make this x squared term have a coefficient of 4 instead of 1, I get an ellipse. The key idea for circles and ellipses is that there's a positive sign in between the x squared term and the y squared term. The difference between them is that circles have the same coefficient, whereas ellipses have different coefficients. Here the coefficient of x squared is 4, and here the coefficient of y squared is 1. We usually just don't list the 1. But notice it's the same exact graph. Now, if we want to turn this ellipse into a hyperbola, we'll want to change this addition sign to subtraction. Hyperbolas will always have a subtraction sign between their x squared term and their y squared term. So changing this to a minus, we get our hyperbola. Remember, the minus sign is like the knife that cuts open our ellipse and inverts the sides so they point outward. And since our x squared term comes first, our hyperbola opens to the left and to the right. They point in these directions. But let's see what happens when we make the x squared term negative and the y squared term positive. We have subtraction between the squared terms, so we know this graph will end up being a hyperbola. And look, it is. The only difference is that now our hyperbola opens up and it opens down. And that's because the y squared term comes first, it's positive, whereas the x squared term is negative. Now, there's one more conic to look at, the parabola. A parabola has x squared or y squared, but it doesn't have both. So in order to change this hyperbola into a parabola, let's change y squared into just y. Now, I'm also going to change the value of 100 to 10, so that way we can see the graph on here. And notice, when we change y squared to y, we get a parabola. The vertex is at 0, -10, and the parabola opens upward. And here's how you can tell if a parabola will open up or if it will open down. We can rearrange this equation and solve for y. So first, I'll subtract -4x squared from both sides of this equation. This gives me -y on the left, -4x squared on the right, and +10 on the right. Next, I'll multiply every term by -1. This will give me 1y equals +4x squared minus 10. And we can easily see that all three of these equations represent the same graph. I could graph this one, and I could graph this one, and see that they all make the same parabola. Since this parabola is y equals, we know it's going to open up or it's going to open down. And since the coefficient on the squared term is positive, it opens up. Now, if we make this coefficient negative, the parabola opens down. So when determining whether or not something opens up or something opens down, you want to solve for the single variable first, and then look at the coefficient of the squared term. Is it positive or is it negative? So we've seen a parabola open up and down, but let's see one that opens left and right. Instead of having the parabola be y equals, let's make it be x equals. So we'll make the x term be a single x variable, and the y term be y squared. Doing that, we see we get a sideways parabola, and it points to the right. And again, we know this parabola opens to the right since we can rearrange this equation to be x equals. First, we'll add y squared to both sides, so we'll get 4x equals +y squared on the right and +10 on the right. Next, we'll divide every term by 4 to get x equals 1/4 y squared plus 10/4. And when I graph each of these equations, I should see that they're all the same. Since this parabola is in the form x equals, we know it's going to open to the right or to the left. And since this number, this coefficient, is +1/4, our graph opens to the right. If instead we make it -1/4, our parabola will open to the left. So remember, y equal parabolas open up and down, and x-equal parabolas open right and left. The sign on the squared term tells us which direction that is. Up and right for positive, down and left for negative.